In a landscape where most mammals would succumb within hours of sweltering heat, there exists a creature that not only survives but thrives with astonishing ease. The camel is not simply an animal adapted to the desert, it is a true masterpiece of biological engineering shaped by countless years of relentless natural selection. Under temperatures that easily exceed 113 degrees Fahrenheit, while the sand burns like metal left under the sun, it walks calmly, as if the extreme environment were merely a minor detail. Its blood contains oval-shaped red blood cells, an extreme rarity among mammals, allowing them to keep circulating even when the body is severely dehydrated. Inside its nostrils lies a highly efficient system capable of recovering moisture from the very air it exhales. What would be a lethal scenario for other animals is natural territory for the camel. It does not fight the desert, it was built for it. And the more we understand its internal mechanisms, the more we realize we are witnessing one of the most sophisticated survival strategies on the planet. For a long time, people believed that camels stored water in their humps, but that is merely a popular myth. The iconic hump is a concentrated reservoir of fat, serving as a powerful source of metabolic energy. When food and water become scarce, the body begins oxidizing this fat, a chemical process that releases not only energy but also metabolic water. Each gram of fat broken down produces more than a gram of internal water, allowing the body to generate hydration from the inside out. This strategy reduces the need to carry heavy liquid weight and concentrates thermal insulation in a single area of the body, making heat dissipation easier in other regions. It is an incredibly efficient system in which fuel storage, water production, and thermal regulation operate in perfect integration, transforming energy reserves into practical survival. The camel's coat functions as a dual-purpose thermal shield, protecting against intense solar radiation during the day and conserving heat when temperatures plunge at night. However, its greatest advantage lies in its ability to allow its body temperature to fluctuate naturally throughout the day by as much as 10.8 degrees Celsius, something unthinkable for humans. This variation drastically reduces the need to sweat under the blazing sun, preserving precious water. When sweating does occur, it evaporates directly from the skin, making cooling more efficient. This external temperature control is deeply connected to its specialized respiratory system, creating a delicate balance between heat retention and dissipation. The result is an organism that manages energy and moisture with remarkable precision, avoiding waste in an environment where every drop of water matters. Inside the camel's nose lies a surprisingly complex system made up of hygroscopic structures capable of retaining up to 60% of the moisture present in exhaled air. As it breathes, the warm air leaves the lungs cooled within the nasal cavities, causing water vapor to condense and be reabsorbed by the body. At the same time, a countercurrent heat exchange process cools the blood before it reaches the brain, protecting the organ most sensitive to overheating. Each breath becomes more than a simple gas exchange. It turns into a sophisticated mechanism for water conservation and thermal control. Thanks to this system, camels can endure weeks without drinking water while maintaining physiological stability in conditions that would be fatal for most species. The camel's blood reveals yet another extraordinary level of adaptation. Its oval red blood cells remain functional even when the plasma becomes thicker due to intense dehydration, ensuring continuous and efficient circulation. This elongated shape prevents the cells from collapsing under extreme water stress. When the camel finally finds water, it can drink up to 30 gallons in just a few minutes, an amount that would trigger osmotic shock in almost any other mammal. However, its blood cells are highly elastic and capable of rapid expansion without rupturing. This combination of structural strength and cellular flexibility allows extreme cycles of dehydration and rehydration without compromising the organism's integrity. Meanwhile, its long legs and wide feet distribute body weight across the hot sand, reducing thermal impact and mechanical pressure on unstable ground. Every anatomical detail of the camel reinforces the idea that it was shaped to face the improbable. Its broad foot pads act like natural tires, preventing it from sinking into soft sand. Long legs keep the body elevated above the scorching ground, reducing direct heat absorption. It has 3 eyelids, including a translucent membrane that protects the eyes during sandstorms without completely blocking vision. Its long eyelashes act as barriers against abrasive particles, and its nostrils can partially close when necessary. Each system may appear independent, yet all operate in perfect synchrony, forming a biological survival machine that is unique. The camel is not merely a symbol of the desert, it represents life's extraordinary ability to adapt to the harshest conditions on Earth. Its body integrates energy storage, internal water production, refined thermal control, respiratory recycling, and blood resilience into a single harmonious system. In a world where climate change is making regions increasingly arid, understanding the camel is understanding the power of intelligent adaptation. Yet these animals face growing challenges, including habitat loss and human pressures that threaten their balance. Preserving them means protecting one of nature's greatest achievements. If you are fascinated by this true living machine of the desert, subscribe to the channel, turn on notifications, and continue exploring with us the most astonishing mysteries of the animal kingdom. Because every species holds a secret, and here, we reveal the stories that make the natural world even more extraordinary.